So now the lecture is recorded, and I can promise you that that I will publish the recordings, so you can review the recordings and get back to some questions, to some problems, to some ideas, to the language, and actually to the problems we have and we must solve. I think that today lecture, and actually the functional programming. Let me ask you another question. Maybe now you have the answers, because we discussed this topic many times. So I still trying to get from you concrete answer, and any answers. I think that relates to the dependency injection is something that it is something that oh, sorry, forgot about this question. This is wrong question. This is not question. Provide two reasons. The concrete cannot be used as an argument of the new operator. It's okay. It's okay. It's okay. Try to answer. What is two reasons? I'm expecting two reasons that we cannot use. We cannot use the concrete type. The concrete type. Let me recall that concrete type is the type is any type that we can use to instantiate an object. And actually, we have two scenarios that we cannot, it's impossible to use concrete type because, and it's question for you. Two scenarios. I'm waiting for two scenarios where we should avoid using a concrete type as argument of the new operator. And the next question that it relates to the previous, okay, stop writing. I think that answer is clear. What is object state? We discussed realization previously, and I'm not going to get back to this topic, but it's very important for the rest. Therefore, I'm asking, what is the state of the object? Okay, but now let me go to, there is one question I wanted to provide answer. I haven't got up today. I haven't got any answer what the signature is. And let me recall you that you can find an example about the signature. I know the signature is outside of the scope of this project, but because I asked about it, I wanted to provide you some hints and actually the answer, because the answer is very, very simple. It is encrypted. It is encrypted result of the hash function. It is encrypted using the public key hash function. It is actually the answer to the question, but here in the example in the class that it's called cryptographical helpers, you can find an example in the method sign and save XML. Here you can find an example how to do it, but still it's out of the scope of these classes. But I wanna only to check if you know, because answering to this question is required on the final exams, during the final exam. Therefore, I think you should be aware about the answer, even if it's not covered by this class. I am assuming that there are different classes that covers this topic. And next question that also relates to the previous, it is also an opportunity to get easy active points. It is describe the difference between delegates and events. We discussed both previously, and I wanted to get to this example in the next class, this class calls anonymous function, because anonymous function is covered by agenda of today. So we must define what the anonymous function is. And here, anonymous function, you have an example. Actually, it is coupled together with another class that calls anonymous function unit test. So both classes can be used to describe, to explain what is anonymous type, an anonymous function. At the very beginning, it is very important note, I think, that we can avoid using anonymous functions. We can avoid it. So it is not required. And actually, in previous languages, in the old language, this old language doesn't have concept like this, anonymous function. It is something new. But it is very important for the rest of our classes. Therefore, we must be sure that we are understanding what the anonymous function is. And the anonymous function is coupled together with functional programming. Where is the question about functional programming? How to implement inversion control? It is another question that is related to the previous. So let me provide this. How to implement inversion control in the language terminology is very important. That you will use language terminology, not just describe what is inversion of control, that is dependence of one object on the another object. So language means that we are talking about design time. Oh, I don't have direct question. I don't have direct question related to functional programming, but I have a question to make sure that you understand what the functional programming is. And the question is the state machine design pattern a typical scenario to apply functional programming? To check if you understand functional programming, because the functional programming is used in the anonymous function class. This class actually implements this pattern. So we have three states. It is arrow handler, active handler, and idle handler. So we have three states. And actually we have, so three states of this state machine is implemented using the concrete classes. We can instantiate these classes. And the current class, it is provided by this property, current state handler. And state, it is interface. It is interface to define what is the state, how to describe the state. Go to definition. We can see it's on the top before the anonymous function class. And actually here in this interface we have three methods: go to idle, go to active, and go to error. And there is also property current state that returns current value of the state. I guess it's big definition. State, it's just enumeration. So the state machine has three states, and we can trigger a change of the state using one of these three methods. Of course, sometimes using this method makes sense, sometimes it doesn't make sense. So we have here we must here provide polymorphic approach. Definitely, this behavior of this method depends on the state. Therefore, the answer is it's no. The state machine is not a good example. It's not a good example to use the functional program, because functional programming, previously you provided answers like that it's using function, but it's not, I think, the most important thing. The names, maybe the names comes from using the function, but the most important thing, the most important feature of functional programming you can find in this method. It is the method just control how many letters, how long is a string, selected string, and if the string has more than 10 characters, the result is true. It is less, it's false. So actually, functional programming, it is behavior that using the same data, the process behaves always the same. So we are getting the same result as in this example. The most important thing, we don't have states. We don't have to take into consideration that the process is stateful. It must be stateless. It must be stateless. State machine. It's a typical scenario where we have states. So functional programming is not a good approach to implement something like that. But still, here we can use functional programming. For example, this method. Do you know how to call this method? Let me ask you. We call this method predicate. What is the predicate in the language terminology? The answer you can find on the screen. In all of the, if you are using this method, always the result is predictable. So always we can predict the result depending on the input. We can predict the output. It is functional programming. Now, so anonymous function is a part of functional programming because first we are using the function, so it means that the functionality doesn't depend on the state. It's not completely true, but the idea is to provide something that doesn't depend on the state. Always works the same way. For example, here we have a method, and this method, consistency check. This method is a very good example of a predicate, because we are testing. We are always doing the same. So always the operation doesn't depend on the state of the state machine. Always the operation is the same. So we are using here delegates. We are calling this delegate, providing us the parameter, providing a condition. So we are checking if the current state handler is not null, because it could be used as an assertion in the testing project. And this method is provided here only for the testing purpose. is provided only for the testing purpose. So in any case, I said you previously that it's forbidden to provide special functionality only to the testing purpose. It is forbidden. It's something that you should avoid. It is just, we can recognize it as an error, not just a warning. It's just error. So do we have an error here? But on the other side, sometimes we must test conditions that it's private, that it's encapsulated inside of a class. In this case, it is not the case here because the current state handler is public. But we can imagine that sometimes it is very useful, for example, to check something that it's private. In this case, it is impossible to provide any testing from the outside. Next, what is very important, it relates to the task 1. In task 1, there is required to use the abstract API. If you are using abstract API, the question is, for example, for the layer, if we are talking about the data layer, so let's assume that the anonymous function is in the data layer. And we must provide an abstract API. Therefore, we should here define an interface that is abstract. But it is impossible to create object from abstraction. In this case, of course, so next, the question is how to obtain API, how to define for the API a boundary. Usually, we can use boundary that this prefix. If something is public, it's in the API because I can use from the outside of the assemble. Additionally, if we have boundaries inside of the assemble, we can use usings to define what it's available, what we can access or not. But here you can see that consistency check is used in the unit tests. So let me prove it. Go find all references. And for example, this is first place where I'm using this method. And this method is located in the testing process, in the testing testing project. So the question is about the encapsulation, because according to the language rules, internal means that consistency check could be used only inside the project. But here we can observe that it's called from the outside. The solution for that, it's actually not solution. So it is an example. It is a good example that we can solve two problems. First problem is that we have something that is dedicated. Doesn't matter if it's data or functionality. That is dedicated only for the testing purpose. This attribute. So, in case of debugging, this method has been added. It is provided after compilation. But if the environment is not debug, if the environment is released, this block is removed. So actually, the block is removed. Therefore, it's impossible to call this method because the method doesn't have definition of the of the block. It is like in the partial classes, in the partial method. It is more or less the same approach. But what is the consequence? To remove something like that, we must be sure that the method doesn't return any value. It must be procedure, because it's if the method is a function and provides a value, it could be added to an expression. It could be part of the expression. It could be argument in the expression. In this case, if this method is part of the expression, it's not easy to remove it from the expression. If it's just call instruction, call statement, it's no problem to remove it because we are removing functionality. But if it's part of expression, we are removing a value. It is more complicated because all the operations provide a result, assuming that all the arguments are defined. So it's impossible to remove one of the arguments for operation. Therefore, we must, in situation when we must provide a result, we can use, previously I asked about it, inversion of control, because here the method is called by the different class, by different project, and we must change the control. We must move the control to the independent class. The best actually, there's the only way using this language, it is to call a method that comes from this independent environment. Going to this environment, we can, for example, see that this method is called. This method comes from this object. It is a variable, but this variable refers to an object defined against this type, using this type, and we are calling this method. It is inversion of control. So the answer of how to implement inversion of control is to use delegates. It is the correct correct answer in all of the cases, actually, because assigning a value to an dependent object, to injected object, to object that is provided as the object is created using a different class cannot be recognized as reverse of control, because actually we are not moving the control to the different object. Therefore, the only possibility to implement inversion of control is using the delegate. Therefore, it is very, very important, as you know, because this project design pattern as delegates, because events is also delegates. Let me recall, events are also delegates. It's delegate variables. So we are calling a method that previously has been assigned to this parameter. Because the delegate is a reference type, so we must have create an object, and this object refers to a method. It could refer to many methods, not only one. But in this case, it refers only to one, this call text result. So you must analyze this code to get more. Now I try to pick definition to prove that the class, here we have the class that we are using to create an object, and reference to this object is assigned to call backup result. Sometimes we can call it callback as injection of control. It is typical example when we are calling back something. And at the end of the day, the most important thing is that we are here, we are transferring a value, because this parameter is assigned to the local variable, and in the next assertion we are checking this value. So after calling, we are expecting that here the value is true. So it must change, because at the very beginning we are assigning here false. It is proof that we are calling this method. Of course, actually we are not going to prove that we are calling the methods, but we are going to prove that we are transferring. This way we are transferring a value. We are transferring the value. Usually you are using also the term communication. That, for example, the layer communicates with another layer. So the layer above communicates with the layer below. It means that, referring to the layered architecture, that because the layer below cannot access the layer above, so it is impossible to communicate something from the layer below to the layer above. Of course, it is not true. Of course, it is not true, because we are talking about two independent program stages. If you are talking about design time, we are talking about the delegates, like about methods, about assigning values. And in this case, it's possible that the layer above get access to the layer below. What it means, get access? It means that use types. So we can, for example, here from the test, can use all the definition in the anonymous function. This relation is only one direction, from the top to the bottom. But during the runtime, we can expect that the anonymous function calls the method here, this method, that it's provided by the layer above. Here we are providing the method that must be called, and this call we can use to transfer the data from the layer below to the layer above. But now we are talking about runtime. So it is very important thing to distinguish between using a type, if the layer above use only types that it's in layer below, and at runtime we can talk about the, for example, communication as a transfer of data, but data is only available. We can talk about the data during the runtime. I hope that it should be clear. I will check it during the project in your programs, especially in task 2. It is very important. If you are talking about the MVVM, model view model, model view model, it is layered pattern. Also, I expect 3 layers. And it's very important that the layers view layer inform view about modifications. So the communication during the runtime should be possible. But during the design time, we can, in the view layer, we can use only type from the view model. So now is the question, what is the anonymous function? Here, you can see that there's its question for you. What is anonymous function? Because now I can provide you some examples here in the same test project. We have an examples that that defines actually what the anonymous function is. So actually anonymous function, talking about the anonymous function, we can distinguish anonymous function as anonymous method and lambda expressions. Two different concepts, but at the end of the day, we must understand the differences, the real differences between this concept. In the next method, anonymous method, for example, we can see here that we have a delegate variable. Callback text test delegate, it is a type. Pick definition can prove, we can use pick definition to prove that this type, it is the delegate. And these delegates we can use to create events or delegates variables. This parameter, it is delegate variable, but somewhere over here there should be, here is also an event. It is variable, but still event handler, it is a delegate. It is a type. It is a type. So we can use delegate types to create delegates and events. What is the difference? As usual, type, it is set of values, possible values, and set of operations. And this time is exactly the same. All delegates, it is set of values. In this case, the values are references to the methods. So objects that refer to the methods, to selected method. The class, it's available, but it is for us not very important because it is class. It must also provide some functionality, and we have functionality like assign new value. We can functionality like trigger, call all the methods, assign it to the delegate or to the events. So difference between the events and the delegates methods, because we don't have event type. The event is always variable. Could be only variable. So could be a value holder, could be type, and keyword event. But in case of delegates, we can distinguish delegate type and we can distinguish delegate variable. So here in an anonymous method, now we are talking about the method. And in this, what is the difference between the delegate and events? It is that some functions for the events, it is not available, cannot be used outside of the class where the event is defined. For example, here we have an event, and from the outside of this class, it is only possible to add a method to this event and remove it is not it is impossible to call, to trigger the call of these methods. It is impossible, even if it's public. If we have access to this delegate, so there is not symmetrical access to the methods. Some methods are available outside the class, but some methods are not available for the user of the event. But for this delegate, we are assuming something like this. So the question, what this? What this? If it's delegate, if it is according to the type, we can set that this value holder, this variable, must provide only references to the methods. It is set of references because it is assignment. We can assume that on the right side is it is a set of methods of if it is just one method, but this method is added by the assign, so it is not only assigning, but it's also clearance of the set in this value holder and adding new value, adding one single value. So it's method. It is method. If it's method, we can distinguish formal arguments to be used to as you like this term for communication, actually to transfer the value, from outside, from the caller to the method and back from the method to the caller. Sometimes it's also possible, depending if the value is in, out, or ref, could be in both directions. We can assign from the outside to the method and get the value back. But additionally, we can from this delegate we can guess, because the delegate type also provide information about expected signature of the method. So we are expecting that to this variable will be provided only references to the method that doesn't return any value, so because we have void as the result of a method, therefore it's procedure, it's not function, and we have one parameter. Input parameter. And here we can see that actually we are not returning. Here we have one instruction. So this part is block of the method. And this part is just block of the formal arguments. So we have everything as in the method. Here, for example, we have a method. It is list of formal arguments. It is block of operations. Here we have block of operations, of instruction, of statements, and here is a list of formal arguments. The only we don't have is the name of the method. Here we have a name of the method. So we can, it is not the case here, but here it is the case that we can call the method. We can call the method using the name of the method. Of course, here the method doesn't have name. So what is anonymous? Anonymous function Anonymous function is a method that don't have a clearly stated, defined name. But without the name, it is impossible to use something. If we don't have a name of the method, it is impossible to refer to this method. It is something that actually doesn't exist. And from here we can see that this delegate can be called. So it can be used. It can be used for. It can be the delegates can be used in a call in a call statement. So actually, we can call all of this method assigned references to this variable. But so instead of the name of the method, in this case, we must use name of the variable. But in both cases, we must have name. We must have name. So the question is, what is the reason to use? What is the reason to use anonymous functions? What is the reason to use the delegates, variables? Because everything we can do using the names of the methods. Of course, there is only one reason. I'm not sure if you know that this way we previously, without object-oriented programming, we implemented polymorphism. It can be used. In any case, we have polymorphic problem, because depending of the expected functionality, we can use different value of the value holder, so we can change the functionality here. So we can recognize this variable as an abstract definition. Abstract because this definition, for this definition, is not provided functionality is exactly the same as in case of the interface or the abstract class and abstract method, that we have just a name and signature, but we don't have functionality. But here, additionally, because it is part of a statement, additionally we can provide dynamic polymorphism, because we can change behavior during the runtime. In case of the abstract classes and interfaces that must be inherited to provide concrete classes, to define concrete classes that can be created as an object. So it is impossible. It is limited. So all the functionality must be defined during the design time. But here also, because this method provides very concrete functionality. So actually, it provides definition, but it provides definition of the functionality during the runtime. But inheritance provides functionality during the design time. It is a very important difference between abstraction and polymorphism we have at design time and at the runtime. Actually, in the next line, you can see that we can use in this language. It is related only to the language, that for the same variable we can use different syntax. So what is the reason to provide for the same two different syntaxes? The only reason is that something is simpler. But we know that we don't have measure of simplicity. We cannot prove that this way something is simpler than in the previous way. I'm trying to control the time, so we must go forward. Next, it's so it is one anonymous function called anonymous method, but also we have anonymous lambda expression. Lambda expression. Let's see. It is exactly the same functionality. It is exactly the same what we have over here. It is the same we have over here. It is exactly the same over here because here we are expecting a delegate. Therefore, here the parameter, the current parameter must be just a method, and this method must be not only method, it is reference to the method, and actually we must provide a delegate variable. Here we must provide a delegate variable. So it is next step of simplification. It is next step of simplification because this way we can avoid many many additional keywords. So, but the problem is how to understand what it means. Actually, what it means here, because here we know what the assignment means. We are assigning, we are transferring this value to this variable. But what it means here, we can guess on the left side we have arguments. On the right side we have a body of the method. We have a block. It is sequence of instruction. But this, so it is, I don't have this question now, but the question is, what is the difference between the anonymous method and lambda expression? What is the difference? And the correct answer is, please make note, put note, that the only difference is syntax. Only the syntax, exactly, because the meaning is exactly the same. The semantics is exactly the same in both cases. In case of the named method, in case of the anonymous method, and in case of this, of the alpha lambda expression, we have exactly the same functionality, except the syntax. The syntax is different, and the syntax could change. And because it is one reason that you should avoid lambda expression. In any case, you have any problems to understand what it is, because you can use anonymous method in case that the variable that you don't have polymorphic problems. You can use just named method. The syntax is exactly the same. But let's see on this example, on this variable. This if you are following me, it is 68 line. So here we have exactly it's a similar situation where we have a variable, delegate variable function. It is a delegate, and on the right side we are assigning a method. But here we are using lambda expression syntax. It is lambda expression. So, for example, we can here it is predicate. It returns logic value, true or false, Boolean, and actually it checks if the parameter is less or greater than 5. and we can check how it works here. But here is something different. So let's check if the expression is, because on the right side we have something similar. So the question is if it's exactly the same. Of course, syntax is different, but the question is if the meaning is exactly the same. So here, if we have here a delegate variable, if it's delegate variable, it is as expected. Right side, it is expression that the result of this expression is reference to a method. Therefore, we can assign. But big definition of this, big definition. Can you see? It is class. It is not delegate. It is class. So we can not say that the variable, delegate variable, lambda here, that lambda is a delegate variable. It's something else. It's something else. Let's try to do something like that and check if this right side is exactly the same as this. So I have made copy of the line 68 and put on the right side of this assignment. And you can see there is an error. So it is not delegate variable. It is not delegate variable. Actually, we call it expression, and we call it expression tree. So this right side, it is expression, but by the compiler, it is not evaluated. It is compiled, and the result is inside of the lambda. So actually, the lambda is holder of an expression. It's not just a delegate. It's not reference to a method. It is expression. If it's expression, it must be executed, but it must be executed during the runtime. It must be executed during the runtime. Here, during the runtime, we are assigning delegate. So we are creating an object for the delegate and assigning the reference. Here we are transferring a delegate into an expression. So the right side is an expression, and probably it is impossible for you to check the error, but the error is that the syntax. The syntax is carefully listen. The syntax is too complicated. The syntax is too complicated to convert. It's too complicated to convert something into the expression tree. So the previous means exactly the same. The only difference is that the syntax is simpler for the compiler, of course, only for the compiler. And the compiler has some rules that can be used to measure simplicity of the expression. If the expression is simple enough to be converted. Of course, it's also possible to call this expression, but additionally, here we are just calling, we are referring to the variable. Inside here, it is actually called to the function. So we are calling a function, and here we must first evaluate expression. From the evaluation of the expression, we are getting reference to a method, and after that we can call call the method. It is, I'm spending a lot of time to trying to express this, to explain this, because it is the most important key. It is the most important functionality. This functionality is agreed. This functionality is related to this language, but we can use this functionality in what we call language integrated query. Next lessons will be covered, will be dedicated to discuss access to the external databases. And getting to the data from the external databases, we'll use something like that. The question for you is why? First question is what? Because still there is a possibility to delegate in all of the cases. Doesn't matter if it's an anonymous method or if it's lambda expression. In all of the cases, it is a reference to a method. Therefore, the question is why we need alpha expression, lambda expression. Sorry, lambda expression. Why? What is the reason we need to apply lambda expression? Partially, answer was in a previous couple of minutes. The next event, the next method. Let me call you, because now I'm going to go to the next topic, to the extension method. I hope we have still time. So the next question is, what is an extension method? But the context of the syntax. Now I'm asking about the syntax. What's the difference? Previously, you asked me about the concrete type. So what is difference between concrete and not concrete type? But now the question is about a method. Let's compare the extension method to the other method, because it's still another method. The method has a name, a block, parameters. It could be static or not, but in this case it could be also the extension method. Let me get back to the event test method. Here you can find some proofs of what I said previously. For example, here we are trying to call. Sometimes, in this case, we are trying to call an event. So it is variable. It is value holder, and this value holder has references to the methods. So the question is why it's impossible to call these methods from here. It is because the call operation is not available from outside of the class. The same we can observe here. Here we are assigning new value, but we are adding new value. But if we are trying to assign, it means that we are clearing the set and adding one item to this set. And it is possible from outside. It's only possible to add new method, and it is impossible to call. To make sure that full control of the behavior of the communication. In this case, we can use two terms. Actually, communication, calling of the method, it means communication because we are calling the method, we are providing to this method actual arguments. Additionally, we can use the term inversion of control. Therefore, because if you are calling this this event here, we have an event on state change, find all references. So inside this inside of this class, we can call this on state changes event and provide current values, provide current arguments, current parameters. Therefore, actually, we are during the runtime we are transferring the data using the call. We are transferring the values, and actually in this case we are calling something that previously was provided from the outside of the class. Therefore, this is a typical implementation of the inversion of control. So we are changing the sequence from the sequence inside to the sequence outside of the class. Okay, I think it's all about anonymous classes. I hope that we have a lot of opportunities to get to these things. If you have any question, just review these recordings. So probably you can guess, you can get answers to your question. If it's impossible, of course, ask me during the consultancy, because now there's no time to discuss details. For me, I'm expecting that in case you have any question, you provide me this question in advance. Therefore, it's easier for me to provide appropriate example, to find appropriate example, to discuss not in the context of general rules, in context of an abstraction, but in the context of the concrete code in selected examples. Okay, let's go to the extension method. So the first question is, what is the difference between the extension method and other methods? But now let's talk about the syntax. So will answer me about the syntax. I try to provide you an answer related to the you are answering me to the semantics, but I ask you about the syntax. So extension method example, it's test, but here we have examples. And one of the examples is here, line 24. So it is static method, but it's extension method. We can observe that the only difference that we have, it is this prefix, this keyword. Sorry. Oh no. I must return to the beginning. So this word that is a prefix for the first parameter. It could be used only in front of the parameter. And in the literature, in the references, you can find explanation that actually the method extends a type. So in this case, we have string. It is a type. And we can, this way we can extend the type. Of course, the problem is if it's true. Okay, are you still answering the question about the semantics? Because I have another question for you, and now it's time to explain the differences in context of the semantics, in context of the meaning, in context of the meaning. Copy. Oh, shit. Sorry, but I'm not very polite. What is the difference between usage of the extension method and static method. So as I said previously, we can distinguish, because the extension method must be static. Therefore, we can compare extension methods only to the static methods. But instance methods that are defined are dynamic classes, or proper, or classes, or even interfaces, means something different. But here we can compare what is difference between the statics and extension method. In both cases are static, but additionally here there is this, in case of the, if we are talking about the syntax. If we are talking about, I haven't got any, there's a lot of answers to the previous questions, but the answer is there's no differences. So actually, the extension methods behave exactly the same. Now I'm talking about the method. I'm not talking about usage of the method. So I'm not talking about how to use the method. I'm talking only about behavior. So actually the behavior is exactly the same. There is no differences between meaning in both cases. If it's this or not, behavior of this method is exactly the same. So the question is, first, what is the difference? Additional question, maybe let's answer first to the next question related to differences between usage. Okay, so let's go to the usage. But you have another question. You haven't? Oh, there is a lot of answers. I hope all the answers are correct. But now let me ask the next question. Can we call extension method if it overrides instance method? It is a hint. It is something that we can use to answer the question, what is the reason? Because actually the references, again, I'm trying to see to refer to the references to the books and to the publication, to the real publication, not to the Wikipedia, is that the method extend a type. So actually it can be used as an instance method. And actually it is more or less here. For example, we can string, it is variable, and split, it is big definition. You can see that it's part of this class. So it is instance method defined as a part of definition of the string. And here we are using a dot. It is operation. Actually, it means that we are calling a method. It is just a selector. So we are selecting from the object. Now we are talking about the runtime. So you are during the runtime, we are having the reference to a string. We can select a method and call this method, and in this case it is its function. So it returns integer. So we can it returns integer length after removing all the empty characters. So here we have the next static method. is the same. We have just this in front of the int integer. So we can say that this method extends the integer. So it can be used. It can be used as an instance, provided that integer is complex type. But in all of the cases we have complex types. The only difference is that we have structures and classes. In this case, as you can see, it is structure. So even in this language, even if the value is simple, because this definition doesn't provide selector, doesn't provide possibility to select part of the value. It is complex type, and actually even can be recognized, for example, to check if the value can be divided by 2. It is next extension for the string, source string, and now we try to find if in the source string we can find characters provided by this parameter, by the value. And in this case, to prove something, I'm throwing an exception that is not implemented to make sure in the test, to make sure that I'm not calling this method. Because if you are calling this method as a part of the unit test, I will get the result, negative result. I will get a red. So the test doesn't pass, is not. So it means that something is wrong. Something is wrong. And additionally, here it is next extension method. In this case, we are extending our interface. Go to the definition, pick definition, maybe it'll be easier. So actually we can provide, we can use as a type interface an abstraction. Of course, referring to the dependency injection we are discussing over and over, you can see that it's an example where we are using an abstraction, but doesn't mean that here we are using dependency injection. It is just to show you that in this case, it is possible to do something. For example, we can check this parameter. If this parameter is null, has null value, so actually doesn't have any value, So go to the unit test to prove some features of the extension method. First, in this line, you can see that it's possible to call the extension method as usual. It is possible to call it as a static method. So answering to the question if it's possible to call the extension method as a static method, from this example you can see that it is possible. And here we can check, for example, that this word count here, that the result is always false. So it's something like, predicate, but it's static method. It is extension method. But of course, static method could be also used as a predicate. The only requirement for the predicate is that it returns false or true for selected parameters. But the responsibility of the predicate is to check a condition, if the condition is true or not. So in this case, we are checking word count. Here we have word count, and here we can check if it's even or not. But additionally, from this line, you can see that extension method could be referred using the selector operator. Testing string is just a value. It is a string value. And here the dot means that we are selecting from this object, we are selecting a method word count, but actually we know that the word count is defined outside of the string. It's impossible to change the string definition because string definition is sealed. If it's sealed, we cannot derive, we cannot inherit. It's impossible to create to use for subtyping. But still we can use syntax that it's provided available for the instance items. And previously, to use both methods, we need to use two lines, two independent statements. And additionally, here we are using working variable, private variable that we are using only inside this method. We are assigning here a value, and this, it is not true. Everything happens in only one line. I think it is the main reason. It is the main reason that we can using extension method could be helpful, because you can use it in a one line without using additional variables, but it provides additional complication because it is impossible, for example, to test internal values. For example, if we have account some problems with evaluation of the expression, here we have expression. This one is expression, and this expression provides current value for this as a parameter, as a current parameter for this assert method. Here you can see, so it is one what you must note. First, it is possible to use calling of this method, syntax of calling of this method, exactly the same as for the instances. Therefore, we can say that it expands, but actually it doesn't expand anything. It is just syntax of the call. It is all. But it is also very, very important. It is crucial for the next lessons. Therefore, you must remember it by heart, that we can use different selection syntax for the extension method. Therefore, we must use extension method because it is required for real life, for outside of the language integrated query. I'm pretty sure that it is not required. So you can omit all usage of this method. Here you can see that actually using the same syntax and referring to the instance method, we are not calling the extension method. So if there's any collision between the extension method and the instance method is called. Here we can see that the test passes, but In case of extension method, as I said previously, there was an exception. Null call. Here is an example where we can call. You can see that the same syntax we can use to call a method from an interface, but the variable is null. In case of the instance methods, it calls exception because instance methods requires an instance. It requires an instance, but in this case we don't have any instance. But still we can call this method because the compiler converts this. No, this one, but maybe it's easier this way. Here we are calling this. We are calling this my interface. It is of this type, my interface, and we are extending this interface in this class. So the name of the class doesn't matter. Sorry, it is just name of the method. Sorry, the name of the class is over here. But what happens during the call? So the compiler converts the instance call into the static method call. So the variable, the value from the variable is passed as the first parameter. Therefore, we are calling the method, and we are providing this method, and we are providing the value using this parameter. Therefore, we can check it, and in case if it's null, we can no, in this case, for example, we are throwing an exception. Okay, so it is everything for today. Time is over, so we must finish for now. And there's another topic related to the task 2. I think because the task 2 it's still the same. I have added only the checklist. Therefore, for you, it is you must provide me if you have any problems with understanding the checklist. As it was previously, just provide me question, meet with me, or ask me in any available way to get answers to this question. But I hope that the task is still the same. The only difference is that now you can also use the checklist. So I think there's no good reason to waste time to discuss. If it's any reasons, if you provide me any reason to discuss the checklist as independent, so I need a slot for discussing, I will book a slot for you for the next seminar. I'm pretty sure that we have time, so I can organize for you a slot that can discuss some selected question, because I think it's your homework. Therefore, you should spend time to answer your questions using, of course, the sessions, the seminar, and the project. So I'm switching